Okay, this is a holiday homework for week 3, Sec 2, question 1. Question 2, 3, 4. Question 5, 6, 7. Question 8. Question 9. And question 10.
Okay, briefly go through answers for holiday homework, week 3's work. Question 1, part 1, we are expected to write an equation in terms of x of the amount of money that each person should pay. So they spend $72 altogether, the x to x people. So 72 over x is the amount that they have to pay. And when 2 people added, so they spend another $26 extra. So total is $98, but total number of people is x plus 2. So the difference between these two amounts is $1. So this dollar and this dollar. So $1. So now we have an equation with fractions. So we will get rid of the denominator of the fractions by multiplying the common denominator of x times x plus 2. So therefore, when you multiply x times x plus 2 to both sides of the equation, on one side, this is there are 2 terms, so you use distributive law, multiply to each and every one of them. So in this case, you have 98x minus 72 times x plus 2, then equals to, on the other side, if you multiply this x and x plus 2, you'll get x squared plus 2x. So with all these terms, you rearrange. This is the only x squared term, and then there's 2x, there's 98x, there's 72x. So you rearrange all of them and put them to one side, and then the other side to be equals to 0. Okay, and so you are getting rearrange, you get x squared minus 24x plus 144 equals to 0. This is what you're supposed to show. Okay, and then this next part here is you're supposed to solve this equation. You can see that this is a perfect square. This left hand side is a perfect square because 144 is square of 12, and then this middle term is twice 2 times x times 12, which is 24x. So therefore this can be factorized to be x minus 12 whole thing square equals to 0. So there's only one answer. So the only answer is x equals to 12. So when x equals to 12, the amount of money that each person has to pay will be 72 divided by 12, which is $6. Okay, question 2a, you have an equation like this. We always bring all of them to one side. Don't do cancellation. If you do cancellation, you're going to miss out one set of answer, which is p equals to 0. So you always bring them to the same side and keep one side to be equals to 0, and then you go and do factorization, bring out the common factor of p, and so you have p times 3p minus 5 equals to 0. So either a p is a 0 or 3p minus 5 is a 0. So p is a 0 or p equals to 1 and 2/3. Okay, next question, also solving equation, but now you can see that on one side it is equals to a 1 there. Okay, so since it's equals to a 1, that means if we were to have an equation like this, we will never have 1 on one side, because otherwise, if you were to think of it as like if you have 2 factors multiplied together to get 1, then what will one of them be? So you may say this one equals to 1 or negative 1, negative 1, and then there will be a lot more other answers, 2 and half, or negative 2, negative half. There will be infinitely many possible answers. So we will never try putting one side to be a non-zero. We must always put one side to be a 0. Okay, so if you put one side to be a 0, that means you have to get rid of 1 here. So to get rid of the 1, you subtract 1 from both sides, and then this one here, you can expand out the whole thing to get and simplify, you get into this. Okay, quadratic equation again, so you try to factorize by using the cross method. So you are going to get 3x plus 2 times 2x minus 1 equals to 0. So either x is equals to negative 2/3 or x equals to half. Next, question 2a, 2c. Question 2c. Next, question 2c. Everything only a square. Okay, so there's only a square, no other term. So what we do is expand out, simplify, you get into here. So 2 is a common factor, bring out, so you have 36. 36 is 6 square. So you are having a squared minus b squared. So you factorize it to be a plus b, a minus b. And so you have a is equals to negative 6 or a equals to 6. Question 3a, given that x squared plus y squared equals to 17, x times y equals to 4. So if you want to find out what's the value of 2 times of x minus y whole thing square, it's just like a times b squared. It will be a squared and b squared. So a squared and b squared. Okay, a squared get you 4 and b squared get you this expanded form. So this expanded form, the x squared and the y squared combine together to get 17. And then 2 times of xy is 2 times 4. And so your answer will be 4 times 9, which is 36. Question 3b, you're supposed to multiply 3a squared minus 1 into 2a cubed. So this is the product. And then after getting the product, you're supposed to subtract this product from the sum of these two. So the sum means you add up. Sum add up, then subtract away this answer. So you group them a power 5, a power 5, a power 5. So you have 3 terms of a power 5. Then next is a power 3, there's only 1 term. And a power 2, there are 2 terms also, so you put them together. Then next is a, and then next is constant term. So you will arrange them in descending order. Okay, and then you get this answer of 2a5, 2a cubed minus a squared minus 2a. Okay, you will stop here. Don't have to bring out a again and then try to factorize it again. No need. Okay, so this is as long as you put the like terms together and simplify, that is your answer already. Okay, question 4a. Question 4a is there are 1, 2, 3, 4 terms. Usually for 4 terms, you will group 2 by 2. So this 2 together, this 2 together, this 2 together, you take x out. These 2 together, you take 3m out. So when you take 3m out, the x minus 5 and x minus 5 will be the common denominator, x minus 5. And so you have x plus 3m as the other factor. Okay, same for this one. 1, 2, 3, 4 terms. So you group this 2, group this 2. So group this 2, you have b times 2a minus 3. And then this one will be 4a into 2a minus 3 also. Okay, because this one negative times negative becomes positive. So now 2a minus 3 is a common factor. So take it out. So you will have b minus 4a. So this is a factor. This is another factor. So you have factorized this expression. Okay, so these are answers for question 2, 3, and 4. Next, question 5a. 5a is on indices. You're supposed to work out the answer. Okay, first of all, 1.5, you make it to be 3 over 2. And 3 over 2, because of the negative, if we want to get rid of the negative, we take the reciprocal. So we put it to be 2 over 3. Okay, so 2 over 3, so the negative is gone. So the 2 square the square. Okay, then the next one, 3 over 4 square. So there'll be 9 upon 16. And then divide by This one I want to get rid of the negative power also. So in order to change it to positive, I take the reciprocal of negative 2. So negative 2. Okay, 3 to the power 0 is 1. Then to the power negative 1. So 1 to the power negative 1 is 1. And then this 9 is actually 3 square. So 3 square to the power of negative half. So you simplify, this will be 3 to the power of negative 1. So to get rid of the negative, you put the reciprocal of 3, which is 1 over 3. And so power is 1. So which is just 1/3. Okay, so here 2 squared, 4. So 4 and 4 cancel with 16, so gone. 9 and 3 squared cancel, also you have answer 1. So 1 minus 1 plus 1/3, which is 1/3, because 1 minus 1 is 0. Okay, this is 5a. 5b is easy. You just put all the numbers together, all the b's together, all the c's together, and simplify. Question 6. I have two simultaneous linear equations. I can choose to eliminate x or eliminate y. I think eliminate y is easier. So I try doing elimination of y. So I use equation 1 times 3, because why? I'm trying to put these two to be the same. So 5 and 3 LCM is 15. So when I times 5 to the first equation and times 3 to the first equation and times 5 to the second equation, both of them having the same numbers here already. So now I'm going to use 1a, subtract away 2a. Why? Because this one, a bigger number subtract a smaller number, so you get a 7x, so no negative. This one subtract this is going to be 0, and this one subtract this is going to be positive value. So 7x equals to 14, x is 2. So once we have the value of x, you can choose to substitute into 1 or into 2, but I feel that into 2 is easier because the numbers are smaller. So I have 4 times 2 minus 3y equals to 11. So 3y is equals to negative 3, and so y is equals to negative 1. Okay, question 6b looks like difficult, but actually it's not. Okay, although there's square root, what you do is just replace square root x by a, replace cube root y by b, and now you're going to get a pair of simultaneous equation, rather simple. So I'm going to use not elimination, I'm going to use substitution method. I write a to be in terms of b, then I substitute into the second equation, and so I can find the value of b. So once I have the value of b, I will substitute back into one of these. Of course, the number 1 is easier. So a will be 5 minus b, which is 5 minus 3. So it's equals to 2. But a and b is not answered yet. What we want to find is x and y. So you put back square root x equals to 2 and cube root y equals to 3. So x will be 4 and y will be 27. So this is up till question 6. Question 7, the equation of a straight line L is given to be 2y plus 5x minus 4 equals to 0. What is the gradient of this line? So we rewrite the equation into negative 5x plus 4. So y will be negative 5 over 2x plus 2. So the gradient of L is actually negative 5 over 2. Okay, next we want to find out the value of k if the point 6k satisfy the equation. So we substitute x as 6, y as k, and so we have 2 times k plus 5 times 6 minus 4 equals to 0. So 2k equals to negative 26. K is actually negative 13. Next is you want to find out another line parallel to this given line, and then it passes through the point 4, negative 7. So the equation, we write it to be, because it's parallel, so it has the same gradient. So y equals to negative 5 over 2x plus c. So when x is equals to 4, y is negative 7. So we have negative 7 equals to negative 5 over 2 times 4 plus c. So c is actually equals to 3. So therefore the equation is y is negative 5 over 2x plus 3. So this is the equation of the line. Question 8. To solve for a indices equation. Okay, how do we do this indices equation? This 8 is actually 2 to the power 3. So 2 to the power 3 to the power negative 2. And this is 2 to the power of 2x. Then equals to, this is 4 is 2 square. So 2 square raised to the power of 3x plus 5. Then you raise to the square root of it means times another power of half. So therefore, we are having the 2 and the half cancel off. So we have 2 to the power of 3x plus 5. Over here, because they are multiplied together, they have the same base. So actually, I can add out the power. So the power will be 2x minus 6. So now these two numbers having the same base, so if they are the same, means the power must also be the same. So I equate the two powers, and so you have x equals to negative 11. So this is the answer. Question 8b, want to simplify. Okay, simplify. You can see that they're all different. So if you want to simplify, you have to try to factorize them and see whether they are the same terms that you can divide out. So x squared minus 9, 9 is 3 squared. So x squared minus 3 squared is x plus 3 times x minus 3. And this one here is actually a perfect square. The 9 is 3 squared. The 6 is 2 times 3. So if you were to factorize it, you are getting x minus 3 whole thing square. Divide means times. Times what? The reciprocal. So I take 3 out. Okay, so this one becomes the numerator. So 3 times of x minus 3. As for the denominator is 5 into x plus 3. So now all multiplied together already, we can see what are the terms that we can cancel. There is a x minus 3, x minus 3. Both of them divide x minus 3 squared on the numerator, denominator, so they are all gone. This x plus 3 and x plus 3, they are the same, so when I divide, they are all gone too. So therefore, my answer is just 3 over 5. Next, question 8c. Again, simplify. Again, they are all quadratic expression. So we will try to factorize all. Okay, divide, I change it to times. So the p minus 3 square is now changed to the denominator. Okay, so this one change to the denominator. Then p squared minus 16. 16 is 4 square. So we are having p plus 4 times p minus 4. Okay. Next, 2x, 2p squared. So 2p, and I have 3, negative 3, negative 3. So can I get a negative 9? Yes. 2p minus 3 times p minus 3. So that will be the factor form of this expression. Same for the denominator. The 12, I break it to be 3 and 2. So I have 2p minus 3 and p plus 4. Can you see that when I times this with this, negative 3p and 8p, so 8p minus 3p is 5p. Okay, so this whole expression is the same as this expression. So next is I try to divide. there's a p minus 3 on top, there's a 2p minus 3 at the bottom, so I divide one of them, so I'm left with one more at the denominator. P plus 4 and P plus 4, so when I divide numerator and denominator by P plus 4, these two terms are gone. And when I also divide the numerator and denominator by 2P minus 3, these two are gone. So I'm left with P minus 4 divided by P minus 3. So this is question 8, part C. Question 9. I have a simple sketch here. The question is, we are supposed to find the area of the shaded region. So if I want to find the area of the shaded region, I need to find out what is the x value of this point so that I'll be able to find out the distance from here to here. So what is the distance? That will be my height of the triangle. Then I also need to find out what is this point and what is this point. Then I'll be able to find out what is the length of this vertical length. So after knowing the vertical length here and the height here, so this one we consider as the base and this is the height. So half base times height is our area of triangle. Okay, so we first look at the intersection point. At intersection point, we have the two y equals to negative 16x plus 4, and then we also have 3y equals to 2x minus 3. I'm going to substitute equation 1 into equation 2. So I'll have 3 multiply negative 16x plus 4, okay, equals to 2x minus 3. This one multiply in, I have negative half x plus 12 equals to 2x minus 3. So together I have 5 over 2x equals to 15. Okay, so x will be equals to 6. After getting x equals to 6, so this point, the x value is 6. So from the y-axis, which is origin here, to here, this length is 6 units now. Next, I want to find out the intercept. So at the intersection, at the intercepts, okay, I'm referring to y-intercept. At y-intercept, okay, let me look at the first question here. At first, at x-intercept, the x equals to 0. So therefore, y will be equals to 4. So this will be 1 point, which is y equals to 4. And then also, when I put the x equals to 0, I will have 3y equals to negative 3. So y will be negative 1. So I know this point is negative 1, this point is 4. So therefore, the area, okay, how do I find area? Area will be half base times height. Okay, so what is the base? Base is 4 minus negative 1, which is 5 here. The height is a 6, so I'm actually getting 15 square units for the area. Question 10.
Question 6, answer. You should get a better graph because your scale, if you follow the scale in the question, it is a better scale. So you should draw a better graph. The answers.